aspect under application of differentiation known as approximation. So first things first, let's say I'm given a function. Let's say I'm given that y is equal to f of x, for instance. Of course, if I'm relating y with respect to x, I'll have dy over dx as the value for what? F prime of x. So in other words, I'll put f prime of x. So I'll have f prime of x to be equal to, now listen please, recall from chain rule concept. We said, perhaps first principle, we said if I have a limit as change in x tends to 0 of a function of x plus change in x, next up minus f of x all over change in x. This man here is a formula for solving problem involving first principle. So in other words, I will recall this concept there. So I will have that f prime of x is equal in value to limit of change in x tends to 0. Next up, f of x plus change in x minus f of x all over change in x. So we are here. So I'm applying two concepts. The first concept was, when I differentiate this, I'll have f prime of x. Next up, we come from chain rule formula that says that limit of change in x to 0 is what? F of x plus x, and I have this. Now listen, from here, since we're dealing with approximation, I will change this equality sign to what? Approximation sign, right? In other words, I will change this concept here. That becomes, from here, I'll have f prime of x we are approximately equal to f of x, okay, f of x plus change in x, next up, minus f of x all over change in x. Of course, this man here was equal to, so in other words, I just change it to what? Approximation symbol. Why? Because we're dealing with approximation. So in other words, if this was equal to, of course, we can what? Cross multiply. In other words, I'll multiply this by this. So I'll have f prime of x, change in x, is now approximately equal to what? F of x plus change in x minus f of x. My next task now is to make f of x plus change in x solve the formula. So in other words, f x plus change in x is now equal to, this man comes here, becomes f prime of x, change in x plus f of x. So this is the formula we're looking for. So this formula is used to actually solve problem involving approximation under the concept of application of differentiation. So let's take an example and let's see how this works, right? So the question says, evaluate the value of number 1, evaluate the value of 25 to the power 3. Yes. Evaluate the value for this case. So without pressing calculator, I can actually use the concept of differentiation to get my answer here. So what are my first tasks? First things first, there are some things I need to note. I need from this man here, I need to know the value for f of x. From this man here, I need to know the value for f prime of x. From this concept to this question, I need to know the value for change in x. And finally, I need to know the value for f into x plus in x. So how do we go about this? So my first task says that this is this. Listen, it's just like the task is quite simple. It just they are good for you to guess. Now look up 25. Look up this 25. I'm having cube root of 25. It simply means three numbers. From to put them together, I'll have what? 25. But that number does not exist. So if I say 5 now, 5 times 5 times 5 is 125, not 25. So look for three numbers such that when we multiply them together, it will give you a number that is far or perhaps near to 25. So in other words, let's start from 2. If I multiply 2 times 2 times 2 in 3 places, that's 8. I can't use 8 because 8 is not actually near to 25. Let's do 3. 3 times 2 times 3 becomes 27. So 27 is quite closer to what? 25. So in other words, my task said now, I'll say that let x to be equal to 27, right? So start from 2. Look for three numbers. Start from 2. 2 times 2 times 2. 2 times 2 times 2. I'll have what? 8. I can't use 8. 8 is far. And we come to closer to 25. So move to 3. 3 times 3 times 3, obviously 27. So this man here is closer to, or perhaps, closer to what? 25. So let x be what? That term that is plus 25. So we are here. So after getting x, your next step is to say x plus change in x is equal to this 27. Sorry, is equal to 25. Listen, after getting for your value, you have let x be that value. Your next step is you say x plus change in x is equal to that real number you are given. So my task now is to get change in x. So change in x here is now equal to 25 minus x. So this x comes here, becomes minus x. Of course, we just said x is 27 here, but x is equal to 27 from here. So change in x is now equal to 25 minus 27. Of course, my answer here, change in x becomes minus 2 as my answer here. So listen, the first task, guess for your value. So look for, starting from 2, this is cube root of 25. Cube root means 3 numbers. When you multiply the 3 numbers together, you have 25. But it's not existing. There's no number that will have 3 numbers that I can times together that will be 25. So look for a number that is closer to 25. So I have 3 times 2 times 3, which is 27. Closer to what? 25. So let s be that number. When you are done, move to x plus change in x is equal to that number you are given in the question is this. So what's the next task? Make x solve the formula. So this one comes there is equal to 5. When plus x comes in becomes minus x. Next up, but we said x from here was 27. So anyway I see x here, I'll put 27. Change in x is now equal to 25 minus x is 27. I have this. So this minus this I'll have minus 2. So from here now, move to f of x. My next task now, move to f of x. What is f of x? Your task says it's quite simple. F of x, this x, put it out this way. Go to your question. I'm having a cube root. Cube root means, let's say I have the cube root of a. This simply means a is power what? 1 over 3. So in other words, I'm having f of x. If this x picked out this way, what I need now from f of x is what? 1 over 3, which is the cube root of this. So I'll have 1 over 3 here. So from what? The cube root alone, I'm having this. So this man now is something as saying, what's x? X 27, I have 27 all to power what? 1 over 3. So in other words, if I have y to be equal to x squared, to find my derivative of x, which is equal to f prime of x, which is what? The y over the x is equal to what? 2x. So from here, if I differentiate this one, I'll have f prime of x. So to find my f prime of x for this one, I will differentiate this one. So if I differentiate x for 1 over 3, I'll have 1 over 3x. Next up, 1 over 3 minus 1. Of course, my answer becomes 1 over 3 x to the power minus 2 over 3 as my value for f prime of x. So from here now, I'm going to recall from the formula here and put in my values. Alright, from here, recall that we said to f of x plus change in x is equal to f prime of x change in x plus f of x. So f, listen, look at this. F x plus x is this value 25. So this one is this here, which is what? 25. So this function is telling you that these three roots, I'm after 1 over 3. When it comes minus to f of x. Look at that x. The function itself is what? 1 over 3. From this process, the cube root on its own. Cube root is what? 1 over 3, right? So that's after the cube root. So f there becomes 1 over 3, right? So it's not equal to, it simply means this man here can be written as this. It's still the same thing. So what I'm focusing on is this part here. So what's f prime of x? F prime of x is obviously 1 over 3. Next up, x to the power minus 2 over 3 as my value for f from x. So multiplied by change in x. Change in x is what? Minus 2. Next up, plus f of x. F of x from here is what? 27. This is power there, 1 over 3. So in other words, if I proceed with this, I'll have 1 over 3, which is this guy here, multiply from the concept of indices. If I have x squared minus 1 over 2 or perhaps minus 3 over 2, this can be written as what? 1 over x over 3 over 2 from indices. I apply this concept here. So I'll have what? 1 over x over 2 over 3 right here. So next up, times minus 2 plus the cube root of 27. Of course, 27 from 1 over 3 can be written as what? The cube root of 27. So from here, if I multiply this and this by this, so 1 times minus 2 is what? Minus 2 all over. Next up, look at this. Look up. 3 times this value here will become 3x to the power 2 over 3, right? So I'm having plus the cube root of 7 is what? That's 3. So cube root of 7 is what? 3. Of course, from here I'll have that minus 2 all over 3 multiplied by, observe, this is x squared 2 over 3. X squared 2 over 3 can be written as the cube root of x all to the power 2 from indices concept. So applying this concept here, so this is written as what? 3 square root of x all to the power what? 2 from this concept. This can be written as this. Next up, plus 3. Now from here, I'll have that minus 2 all over 3 multiplies 3 root. What's x? X is, I have 27 here to power 2. So plus 3. So my final answer here, plus 3. Okay. Okay. From here, equal in value to, look up, minus 2 is this, all over 3 times cube of 27 is what? 3. That becomes 3. Next up, this squared here. So plus 3. So from here, from this concept here, from here, I'll have that minus 2 all over 3 times 9, because 3 squared here is 9. So next up, plus 3. So minus 2 all over 3 times 9 is what there? 27 plus 3. So apply your LCM concept. So what's my LCM here? 27. 27 is 27 is what? 1. 1 times minus 2 is what? Minus 2. Plus 27 in 1 is what? 27. 27 times 3 is what there? That's 81. Of course, what's my value of this? Minus 2 plus 81 is what? 79, right? Right? Yes. Over what there? 27. So give an answer, please. 79 over 27 is what? 2.9. 2.9 what there? 925. It's simply not equal to this. It will be what? Approximation sign, because this is the sign here. From here. So this sign is approximation sign, please. So approximation symbol. So just change it that way. So it simply means that if I press this top in my calculator, the value of half is this man here. So you can try it. So the value you have is this man here. So that using differentiation, put down example 2, using differentiation to complete the approximation. I said using differentiation to complete the approximation value of the following without using calculator. So the question goes number 1. I said using differentiation to complete the approximation value of the following without using calculator. The first one says number 1 is 6 the square root of what? 730. So let's find the value for this. And the other question says 2 4 root 1230. So the first one says the second one says 1230. The fourth root of 130. The second one is what? 6 root 730. So I will do number 1, you do number 2, and drop your answer in the comments below. So for number 1, I'm having what? 6 root what? 730. I'm told to solve this using what? Application of differentiation under approximation. So what do you do first? I said look for, now I'm seeing 6 root. This means look for 6 numbers that if you multiply them together, it will be closer to 730. So what are the 6 numbers? If I start with 2, 2 times 2 times 2 times 2 times 2, 2. 1, 2, 3, 4, 5, 6. What's my side, please? That one side, please. I'll have 32, right? Good. 32, right? 64. Right, 64. 64. Sorry. So observe something, please. I use 1, 2, 3, 4, 5, 6, 6 numbers. I started from 2. That's 64. Observe this number 64. They are not even close at all. Most of the 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6. What must I place? 729. 729. Of course, look at this number and this. They are what? Closer to each other. So my task says that let x be the number that is closer. That's what? 729. I said after alright, from here now, after I got it for your x value, next up I said your task is what? X plus change in x is equal to what? This value here. That's 730. Next up, get your change in x. Change in x is equal to 730. This man comes here, becomes minus x. But what's x? X was what? 729. Please give a value here. Change in x is equal to 730 minus 729. You know my other change in x. Change in x is what? I'm having 1 as my change in x value. So I said, when you're here, what's the next task? Go to what? F of x. And what? Put this x here. Next up, your function is what? This one I'm considering is what? Let's say I have root 6 by 8. This is what? This by what? 1 over 6. So I'm taking this guy off here, 1 over 6. Right? So now, this is not equal to the same thing as saying what's x value? This is the same thing as saying what's my x value? X is what? 1. Sorry. 729. 729. What's by what? 1 over 6. The same thing. So to get f prime of x, I will differentiate this 1. Differentiate 1, x is for 1 over 6. I will have 1 over 6x, 1 over 6 minus 1. Have you now? Yes, so you know what? My f prime of x will be equal to what? 1 over 6x by what then? Minus 5 over 6 as my answer here. Right? So now, what's my next task now? Recall our formula. So recall that we said f of x plus change in x is approximately equal to what? F prime of x change in x next up plus f of x. I'm here. So let's put in our value here. So putting in my values, I'll have that this man here, f plus in x is what? Is 730. 730. This f means what? This man here, 1 over 6. So all to power then 1 over 6. So in other words, if I have 6 root 730, this can be written as what? 730 all to power then 1 over 6. This is what I have here. The same thing. What I have here, the same thing. So it's approximately equal to, what's f prime of x first? F of x is what?
1 over 6.
1 over 6x, next up, minus 5 over 6, right? So multiply by, change in x. What's in x?
1.
I have 1 here. Next up, plus, f of x is what, please?
1 over 6.
F of x is what? X to power, sorry.
729.
729, what's power there? 1 over 6. Of course, from here, this is approximately equal to 1 over 6 times, this one in indices becomes 1 over x to power 5 over 6, right? So next up, times 1, that's in x, plus what then? The 6th root of 729. We write this one in indices, right?
It will be 1 over 6x.
1 over 6 times this one alone. Think about the indices, becomes 1 over x to power 1 over 6, right? So times this one here. So times this one. Alright, I'm here. So plus this guy here. We write one indices. I have this. So obviously, if I proceed, I'll have 1 over 6. 1 over 6 times what then? 1 over, this becomes the 6th root of x to power what? 5 from indices concept. So observe this one is not this times this one here. Next up plus, what's the value of this? 3. I have 3 here. So from here now, this is approximately now equal to 1 over 6 times, of course. So I'm going to replace time. 1 times 1 times 1 is what? Is obviously 1 all over 6. Yeah. Next up, 6. I'm saying 6 root x. That becomes into 6 root. What's x value? X is what then? 729. Right? Up to power what? Up to power 5 here. Right? So plus 3. My value here becomes 1 over 6. What is 6 root of 725? 729. That's what? 3. Up to power what? 5 plus 3. Give me value please. 1 over 6. What's the fifth root of 3?
243.
That's what?
243.
2, 4, 3 plus 3. Right? Multiply the denominator for me please. 1 over what then?
1 over 1450.
1458
58.
plus 3. From here, LCM becomes 1458. This man in this is 1. What the man is what? 1. Plus this in 1 is this value.
Okay.
This times 3 is what please?
4,374.
74. Please add numerator for please. I'll have 4375 over 1458. Please divide this for please. So my answer is approximately equal to what? Divide 4375 over 1458 please. 3.00006. So this is correct. This means that if I take a calculator, I punch 6 root 73. Press a calculator. Okay, perhaps if you put a calculator, this answer that you get, that's what you have. So try to check this. Check.
3.0006.
So it's correct. This is correct. So this is like the concept. So you do this man here and leave your answer in the comment section below. So this is how to solve problem under the application of differentiation under